series, we invite learning analytics researchers to share a short presentation about their work and to open the discussion about a topic that they are passionate about. So for today, we are your hosts, Vida and myself, Anushka. We are both members of the Solar Executive Committee, and Vida is a research fellow at the University of South Australia, and myself, I'm assistant professor at Utrecht University in the Netherlands. And it's really great to have you all here from all corners of the world, as we can see in the chat. We're happy that you joined the webinar, and we will have the following structure today. Vida will first explain a few communication rules, just to set up how Zoom works. Then we will introduce our speaker, and after the presentation, we will have time for discussion, so questions from you, the audience.
Yeah, so welcome everyone. So first thing to know, you do have the buttons in the bottom left corner for muting your mic and stopping or starting the video. That's the first thing. So we also can control if somebody's, sometimes there is a noise coming, even that you're not aware of. So, but you know, if you can all mute your mics, you can leave the video on, that's fine. But if you want, you can turn them off. So you also have the chat button down below in the middle of the Zoom screen. So you can start a chat, and you can chat with individually one another, or you can post messages for everyone. So this is where you can, you know, post questions that we're going to read at the end. Some of those questions we're going to read at the end for our presenter. And also, after the presentation, in the Q&A session, you can also raise your hand. And to do that, you click on this button, Manage Participant, and then at the bottom, you'll see Raise Hand button. So for asking questions, that would be easiest. If you have actually problems with your audio, you can write a question in the chat box. That's also fine. And yeah, so one question, let's try to see for a raise question, raise hand option. So if you can say, everybody from Europe, raise hand now. Yes, I've seen a couple of them. Yes, excellent. We have a few Europeans here and North Americans. Few as well. And from Australia, people, I cannot raise hand as a host. And yeah, so this is how it will be easiest to ask a question at the end. So I think that's about it. So Anushka, if you want to introduce Simon. You need to unmute yourself.
Yes, that's a good idea. Yeah, so today our speaker is Professor Simon Buckingham Shum. He's from the University of Technology, Sydney, where he is the director of the Connected Intelligence Center. We already saw the nice poster that he hung behind him. He's one of the founders of Solar, actually, and he has a very impressive body of work in the field of learning analytics, ranging from topics concerning multimodal analytics, writing analytics, and online collaboration. And as he writes himself on his website, his work is characterized by a human-centered perspective. And so a very interesting perspective, I think. And last but not least, I know from personal experience that Professor Shum is also a very inspiring and accessible speaker. And we are very happy that he's willing to join us today to give his presentation. So yeah, let's start. Thank you, Simon.
Okay, thanks very much. And I hope you can all hear me okay. So today I'm going to share with you some thoughts that I'm developing. This is kind of work in progress. And I'm going to introduce you to the idea that learning analytics is a form of knowledge infrastructure. It's got a critical role in developing a knowledge infrastructure for education. And I will be explaining, of course, what I mean by a knowledge infrastructure and what the practical applications of this might be. Before I go any further, I definitely have to acknowledge the team here at the Connected Intelligence Center who's whose practical work and conceptual work is shaping my thinking all the time. So grateful to all of them. And have a look at the KIC website to learn more about them. Okay, so we're going to kick off by thinking about knowledge infrastructure and the remarkable ability that we now have to pull out a device from our pocket and, for example, see what the weather forecast is anywhere on the planet, pretty much. That's a pretty amazing ability. And when you think about the amazing infrastructure that sits behind this, from sensors to models to the ability to predict, it provides an interesting metaphor for what we're about in terms of trying to sense, model, and predict what's going on in learning. And it's this infrastructure and analyses of it which have provided me with some provocations for thinking about educational infrastructure. So this word is one that on the one hand is very banal and refers to all the things in the background that we don't really want to have to think about unless something goes wrong, and then it suddenly leaps to the front of our consciousness. The question is, what is an educational infrastructure that we can trust, especially, and a particularly important question around today as we worry about algorithms and big data and AI and black boxes. So all the thinking on the ethics of algorithms and so forth. But we want to be able to trust it scientifically as well. So even if we had an ethical infrastructure, can we actually justify the kinds of claims that we want to make as learning scientists, as educational researchers? Now, clearly, some people do not trust this already, and you may or may not be aware, but people are literally on the streets protesting against AI in education, in this case at an annual general meeting of Pearson. Now, my view on this is sort of mixed. On the one hand, there are some justified concerns about the role of huge multinational corporations in education, but I don't consider them to be intrinsically evil. What I think we need are informed, trust-building conversations with parents and teachers and unions. A Luddite rebellion isn't going to help anybody. What we need is the ability to have good conversations about what the future role of AI will be in education, how teachers' jobs may change, not that they're going to be done out of jobs, but they may be playing slightly different roles in the future. So the proposition for today is that we're actually in a very exciting transitional moment in the history of educational research and practice, because what we're doing is laying the foundations for the next knowledge infrastructure in education. The infrastructure that will allow us to sense what's going on with a learner and make claims about an appropriate intervention, or as researchers to study learning and make claims about the nature of learning, because we've got completely new instruments to study this. If we're going to study the world through a computational lens, then we need to take some care. Machines see the world through models. And the model is a distorting lens. We're taking data, we are processing this, and then we're taking action on it in some way. And if this is going to be a fundamental way in which we see teaching and learning in the future, we better have a very good idea about how those lenses are cut. Who cut them, and for whom, for what purposes, and exactly how do they distort the view. Because no model, no framework is transparent. We use them precisely because we want to filter complexity, amplify signals, and cut out noise. But who decides what is signal and what is noise? And in any scientific discipline, you have to understand your instruments, what their resolution and limits are, and be aware of how data coming out of them may be partial, incomplete, or uncertain in some way. So if this is where we're going in the field of education, in the field of learning sciences, this is a primary question for us. And my argument is that we need a holistic approach, one that takes systems and systems of systems very seriously, one that places human values, dignity, and ethics right at the center. And that's what I'm going to talk about really today. So this is not going to be an introduction to learning analytics. There are many good introductions to learning analytics. Just Google that and you'll find great introductory videos and articles on that. Fundamentally, of course, we're talking about the intersection between learning and analytics, between pedagogy and assessment and teaching practice and learning outcomes on the left-hand side, and between data science and statistics and text analytics and AI and the world of machine intelligence on the right-hand side. And those are two very different discourses, and that's what makes it such an interesting collision. But as I've argued in more detail elsewhere, there's a very important missing circle, which is the human factors of how we conceive these tools, who gets to be in the room when decisions are being taken, who gets to decide if it's successful or not, and so forth. And this is at the level of organizations and strategy, all the way down to staff training and user interface design, and so forth. Now, what's interesting is that what we do in this little triad here is not just an interesting scientific experiment in a lab somewhere, but there is a large infrastructure that's changing around us and sets the context for what we're doing. We have, obviously, some very big companies now providing us with learning platform services. We have adapt learning platforms. We have data protection laws, such as the GDPR in Europe, and every nation is evolving its privacy laws to keep up with big data and AI. We have publishers as major players now with very large platforms. And we have intergovernmental data sets and national data sets. Add in venture capitalists and philanthropic foundations, and this is quite a web to weave around the business and research topic of learning analytics. And it's this complex network of networks, system of systems, that creates the knowledge infrastructure for what we're doing in education now. When you talk about knowledge infrastructure for education or for science in general, then one book you might think of is The Fourth Paradigm. That's quite a computer science vision, and it says that we can now build on empirical, theoretical, and computational paradigms and move this into a data-intensive paradigm. And that book's available for free on the internet. I suggest you take a look at that if you want to get a computer science view of where the future of research is going. But what I want to foreground today is that a knowledge infrastructures perspective sort of builds on this, but it takes into account the wider systems. It brings a critical lens to look at how the human, as well as the technical systems in science, interoperate to construct, share, contest, and sanction knowledge. And in particular, I want to talk about one particular book called A Vast Machine by Paul Edwards. And that takes us back to those weather forecasts that I opened with. How do data, models, visualizations, science, and politics all come together to produce knowledge about the past, the present, and the future? And, you know, although this is, quotes, hard science, there's still a whole lot of uncertainty in there as well. And you might have noticed the Oh, just to point out that there's a 200-year-old infrastructure. Okay, it's been through a lot of evolution, and the book is very much about how that has evolved. Now, the subtitle for this book is Computer Models, Climate Data, and the Politics of Global Warming. And it struck me that we might just fiddle with that title and say, what if it... Can we imagine in the future a vast machine that operates at different scales that allows us to talk about what works in education and what should be informing policy? Now, let's drill down into what we mean by knowledge infrastructures then. We're talking about robust networks of people, artifacts, and institutions. Okay, artifacts include technologies, but you can see that technology is just one part of the story here, that generate, share, and maintain specific knowledge about the human and natural worlds. And some examples of routine, well-functioning knowledge systems would include, the weather forecast infrastructure, the Centers for Disease Control, the IPCC. Okay. And infrastructures are not systems in the sense that somebody sat down and designed this thing, or even anybody designed it from top to bottom. They're completely emergent. They're ecologies. They're complex adaptive systems, continually figuring out and evolving and trying to maintain their interoperability. And interoperability here, again, does not just mean technical interoperability, but standards, as well as technical socket layers, as well as social practices and norms and individual behaviors. So it's very social and it's very technical, all mixed up together. And I think that we could see the educational ecosystem mirrored here in that sense. It's an evolved system with a lot of different organizations and standards and practices. And Paul Edwards says, well, I don't want to talk about knowledge infrastructure just as a sort of analogy to the transport infrastructure or the energy infrastructure or the weather infrastructure. We need this infrastructure to do science. If you get rid of this infrastructure, you're left with claims you can't back up, facts you can't verify, comprehension you can't share because nobody knows who to listen to and trust, and data you can't trust. And the proposition then is that this infrastructure that is emerging in learning analytics and AI and education and all the other data infrastructures are going to become part of the educational infrastructure. And it won't exist without that infrastructure. Knowledge infrastructures perform three functions, easy to remember, it's 3 M's. They are monitoring the world, they are building models of the world, and they're serving as a form of collective memory of what we said, what we claimed, and we can go back and re-excavate that. And knowledge infrastructures have some interesting concepts and properties. So one is called metadata friction. So obviously there's a lot of climate and weather data, and what they do in climate science is continually go back over that data and want to reanalyze it with new data, with new tools. And they then come across what they call metadata friction, which is trying to understand where did this data come from and who collected it and what tools were they using at the time and so forth. And this is a continual challenge for the field. And equally, I think we're going to bump into this within education. Even analyzing your own data and recovering the metadata, never mind other people's, can be a challenge. And we don't really have good standards for documenting data and archiving it with appropriate context. We've already heard a lot about models, but this telling phrase, everything we know about the world's climate, we know through models. I'm not talking about the difference between raw and cooked data. I mean this literally. Today, no collection of signals or observations becomes global in time and space without passing through a series of models. And equally, machines are only going to see learners through models. We are going to design filters and amplifiers that focus on certain properties in the data, and we better have a very good way of explaining how those work. And I also love this expression, this famous saying from Jeff Bowker: raw data is an oxymoron. There is no such thing as raw data. It has never been designed. Somebody has made decisions about what to collect and how to collect it. Another important concept is infrastructural inversion. So in climate science, they are continually examining where that data came from and what assumptions were made. There's a continual process of self-interrogation. And again, I think this is a very healthy attitude that we're going to need to take into our infrastructure building. We have to keep lifting the lid on our infrastructures. And we've got to equip learners and educators to engage critically with the tools and not treat them as magic or necessarily as always authoritative. I want to note also that there are other people in education thinking about infrastructure. My colleagues just up the road at Sydney University, Lena Markowskater and Peter Goodyear, are talking about epistemic infrastructures, particularly for professionals in teaching. And they talk about information infrastructure and epistemic tools. And they provide quite a rich theoretical lens for those of you interested in this. So, in what senses might we think of learning analytics as constituting, or at least contributing to, an emerging knowledge infrastructure? So let me give you some examples. Firstly, I think that knowledge infrastructure concepts seem to apply to the way that a lot of people are now thinking about learning analytics from a critical perspective, and I've given you a little taster of some of those. And secondly, that learning analytics is starting to display knowledge infrastructure properties at different levels of the system. And I'll show you some examples of that. Now, the weather climate science infrastructure is nearly, it's 150 years old plus. Learning analytics will celebrate being 10 years old next year. So we're new kids on the block. There's a lot to do. But what I'm arguing is that if we know what a functioning knowledge infrastructure looks like, that could help us to prioritize what we do in our early days in order to develop something that will be sustainable and functioning and trustworthy. Now, let's think about different levels in the system, okay? When we talk about learning analytics, some of you may have seen this diagram before. We can talk about it at the macro level, where we're talking about at least the state, if not national, international comparisons. And we might think of PISA school rankings or university rankings here. And at this level, we are dealing with fairly traditional educational data. And it's not really, the worlds of learning analytics and AI in education haven't really touched this layer yet, although PISA, of course, is starting to introduce some computer-supported collaborative problem-solving challenges into its infrastructure. At the meso level, we've got the institutional level, school and university information systems, what some people have called academic analytics, and often dealing with traditional outcomes of, outcomes from courses, as well as all the institutional demographics. Now, it's at the micro level that I argued in 2012, quite a while back now, that was particularly exciting because this is where learning analytics was really kind of kicking in. We're able to track individual student activity at higher definition and start to close the feedback loop to the learner and to the educator about how that student is progressing. And I also pointed out that I expected to see the micro layers informing the meso layers, informing the macro layers, and that we would aggregate user traces up the tree, so to speak. And that similarly, as we built larger and larger data sets at the meso and macro levels, they would then potentially add power to the micro level analytics. So for example, if you are a multinational learning platform company, you have got data at the macro level from micro-level analytics. That allows you to look at what students are doing all over the world in different contexts within a common environment. Okay. So maybe we can use the same layers to think about knowledge infrastructure. Okay. We've got macro-level knowledge infrastructure where we've got scholars and researchers and companies sharing data and models and insights. And there's going to be debate, but perhaps we can imagine an emerging consensus around how do we optimize learning. And of course, within the research community, there is an evidence base emerging about how to design good learning analytic systems and empirical findings, and these are the things we publish in our respective journals and conferences. At the meso level, this is at the level of a given university or school, perhaps. All of the above, but at the level of learning in the institution. Building a knowledge infrastructure specifically tuned to your institutional context and mission. And then down at the micro level, we will be understanding how we do this, perhaps at the level of designing and using learning analytics for a particular course, or even just a particular assignment in a particular course. Okay? So, if we imagine in the future that we were as mature as climate science, what we'd be expecting to see? Trusted data sources, validated models, interoperable data and models, established research methodologies, and government policy held accountable to international scientific consensus. They've all got asterisks because they're on, all of these are contested to some degree or another. That's what the scientific debate is about. But there is still consensus emerging, right? No serious scientist really questions what the Intergovernmental Panel on Climate Change and the science base on which they draw on these days. There are plenty of people who do contest it, but they're well outside the scientific mainstream. Okay. Now, education and learning is a little different from climate science and weather forecasting. Okay, but this is where we should be aiming to go. This is the infrastructure we're building. So what are the practical implications of doing this? Here are some examples. Okay, if we think about at the macro level, okay, fundamentally, we have got to be accountable. The models that we are building have to be grounded in educational research and the learning sciences. We're looking to impact policy and practice. That means we have to make the evidence base accessible. Policymakers and teachers and parents are not necessarily going to read our beautiful journal papers. So we have to work hard to make that evidence base accessible at the state, national, international level. We need to be sharing our models, and perhaps we need to be sharing our data, but learner data is different from climate data, and there are obvious concerns around where that data goes and whether it can really be anonymized. But we can certainly be sharing models at this level. So here's an example of how we make our models accountable and grounded in the learning sciences. On the left, we have the world of learning. Learning outcomes, constructs such as resilience, constructs such as has mastered Pythagoras' theorem, constructs such as can construct a grammatical sentence. Okay. But those constructs are intangible and in the minds of the learner. We only know whether they are actually competent by looking at their behavior. Human observable behavior, traditionally, using pens and papers and teacher observation and all the current conventional apparatus of trying to do assessment, formative and summative. And then on the right, of course, we have the new world of digitally captured behaviors. We can make that a little bit more complex because the digitally captured events down on the right here, from those, our computational models may derive higher order features and higher order features on top of those, eventually to define metrics, which decide these metrics in combination, maybe proxies, computational proxies for some educational outcome that we're after. Okay, and I suggest that perhaps what I'm doing here is actually a form of what in knowledge infrastructure theory is called infrastructural inversion. Okay, what this picture shows is how we are defining computational metrics for a particular educational outcome. Okay, it's like we've picked up the dashboard, which would be on the left-hand side, and we're looking at the roots. We're looking at the infrastructure and the plumbing and the assumptions that have been made underpinning that. Okay, there's a lot more that can be said about that, and I'll give you a few pointers to that later on. We need to make our evidence base accessible. So I want to try and remind you of the evidence hub that the LACE project developed to track the emerging state of knowledge in the field. An evidence hub, which is a concept I developed at the Open University, is a structured semantic repository which aggregates the evidence for and against a particular claim that a community is interested in making. A claim in the evidence hub here, for example, is that learning analytics promotes good learning. Okay, that's a claim. What is the evidence that supports and challenges that claim? And an evidence hub provides us with a way of evolving that knowledge base over time. It's an interactive, organic structure which stands in contrast to a frozen PDF literature review or state-of-the-art report. And I think that concept is one that we need to work on harder. And it has been introduced in relation to the LAC conference, where the LAC conference is trying to index the papers that are published again into the evidence hub. But it's something that could have a lot more life in it if there was a collective community commitment to making our knowledge more widely accessible and indexed. At the meso layer, things should be getting easier, okay? Knowledge infrastructure at the global scale is very complex because you've got huge time scales, certainly in the world of climate science. You've got a lot of geographical variation. You've got a lot of different methodologies, a lot of different instruments being used. And that's why you have this continual adjustment and work to try and get data interoperable and models working on the same assumptions and so forth. Now, as we scale down to the meso layer and the level of the institution, that should help simplify things, right? Because now, in theory, we have a lot more control over where our data came from and how it's structured and organized and what the history was that led to that. However, we also know institutions have long histories. We know that institutional data and knowledge are still pretty slippery things to curate. If any of you are involved in trying to align data within your institution or to manage knowledge, you know how tricky this can be. And of course, if we're actually trying to inform teaching practices, well, we know that they're not necessarily going to change overnight as well. The move to more progressive pedagogy or shifting from current practice to more authentic assessment, those are long processes to institute across the institution. However, that being said, I think that at the meso and the micro layers, learning analytics is where we can really add to the knowledge infrastructure. 3 examples, just to make it tangible for you, okay? We should be able to enable much more effective data flows. We should be able to tune our analytics to the institution's particular needs. And we should be able to co-design very effectively with our stakeholders. Okay, so let me just unpack a little bit more about that. Okay, data flows, metadata friction, those were problems that Paul Edwards was talking about when we're talking about climate data. What does that look like in our world? Well, here's one picture of it. You know, if that is the future learning ecosystem beyond the institutional LMS, Kirsty Kitto, my colleague here, at UTS asks, well, how are we going to deliver learning analytics over that level of complexity? That's something that we've been thinking about quite deeply here, because learning in the future will be lifelong and life-wide, as well as multi-platform and heterogeneous, even while a student is within the walls of the university for 3 years. And that may become a thing of the past. At some point, as students move in and out of the university system much more, in a much more porous kind of way. And one of the things we're thinking about is how data will flow around an ecosystem that's quite emergent, with a huge diversity of data and analytics services appearing and disappearing. So we're going to need an API-based infrastructure that eases the flow of data around and allows us to add models in and take models out much more elegantly. And there are some links there which you can follow through to learn more about that. That's the outcome of a national project here in Australia. All of these slides will, of course, be available after today's webinar. Okay. Another challenge. We want to build generalizable models. Okay. I mean, it's great. You may have built a model that only works in your institution, but typically you're tackling a problem which many other people will be interested in as well. Wouldn't it be great if we could share models and improve them in an open source kind of community? At the same time, when we generalize and scale models, we don't want to sacrifice context sensitivity. So I just want to introduce you to work led here by Antoinette Shabani in her PhD, who's been developing a framework with Simon Knight and myself to try and develop contextualizable learning analytics. So the approach here is to co-design the analytics with the educators and to find good teaching practice that already exists and then augment that with analytics. So we have our educators who live in the familiar world of designing assessment activities and particular tasks and assessment criteria and rubrics. And then we have the strange world of analytics and AI researchers and designers who live in the world of looking for features in the data and trying to design user interfaces that will close the feedback loop. And so we use this sort of gears metaphor to say there are ways of aligning and synchronizing these gears so that they all drive in the same direction. And that when you're designing the task, it might evolve slightly in order to take advantage of the features of the learning analytics system. In this case, it was automatic feedback on writing. And at the same time, we might need to modify the features that the NLP can pick up. We might need to change and tune the feedback we give in the user interface in order to make sure it makes sense to the law students or the business students or the pharmacy students who we are dealing with, okay? But together, these gears can be made to mesh. And the work that Shabani has done is to demonstrate how that works and what the impact is. So that's a way of developing a generic NLP capability, but then tuning it to different contexts and making sure it all makes sense to the teachers and the students. So here's an example of the feedback that the ACA system provides to civil law students, highlighting where they are making significant rhetorical moves. For example, identifying a trend or tendency in the literature, or drawing a contrast, or identifying a tension of some sort in their text, or providing a signposting summary to the reader about what to expect in the text to come. And that feedback looks very different if we're dealing with, for example, first-person reflective writing about an experience on a work placement, for example. Okay, so I want to think of this as what we're doing here at UTS is building a micro knowledge infrastructure, a knowledge infrastructure that builds trust amongst the institutional stakeholders here that what this analytics tool generates is meaningful, relevant, helps teaching and learning, and can be trusted. Okay, so we are, for example, building evidence that allows us to make certain kinds of claims about what happens when you deploy the tool in a subject, okay? We've got claims about the kinds of changes that students make in their revisions, claims about the improvements they make to their drafts, a claim about the impact on their grade of their final submission if they actually engage deeply with Academically's feedback, okay? And this is what this is an example of micro knowledge infrastructure at the micro and meso level within in this case my university. But Academically is open source, and other institutions are now starting to test it in their contexts. And we would hope that the models that they build and the models we build are going to be of mutual benefit, and the insights they develop will be of mutual benefit. We're building educator trust in this. There's a quote here about the improvements they're seeing in students' writing. We're building student trust. Ultimately, the students won't use this if they don't find that it's useful. Okay, so it's like having a tutor or another person give constructive feedback. You know, when you're editing your own writing, you automatically think your work sounds good. You know, but this tool indicated areas where I needed to be more explicit, which I would not have noticed otherwise. By being forced to actually identify ways of arguing, along with the types of words used, it's maybe more aware of the way I'm writing now. Okay, so that's one kind of trust building infrastructure. Another approach that we're taking, this is the final example I'll give you, is to use co-design techniques. Again, to bring stakeholders into the design conversation so that they really feel that they're having an influence over this tool that we're asking them to deploy with their students. So here's one approach. This is work with Carlos Prieto, who's another of our PhD students, very interested in co-design for learning analytics. And he's developed a deck of playing cards that allow stakeholders to literally play a card when they make a contribution to the conversation. And the card has got a particular design. You can see the different features of a card here. And the deck, which you can download at that URL at the top there, has got different kinds of moves you can make in the conversation. And they can play them, lay them onto the canvas, draw lines between them. And essentially, we've got a language that empowers non-technical stakeholders like teachers and students to talk with data scientists and academic researchers about what it is that a learning analytics system should be doing and what the issues will be around, including issues like, you know, what the learning objectives are, what privacy issues might arise, and so forth. Or here's another example using a Jupyter notebook to very rapidly iterate thresholds in the natural language processing tool so that the academics, shown on the left here, can actually see which words will be highlighted in the student's writing and are those words that they would like to be highlighted or not. Again, bringing them in, co-designing with the academics and the data scientists, and then they will see, of course, the decisions that we've taken about thresholds implemented in the proper user interface that I showed you earlier. Okay, so just to wrap up then, if you're interested in this topic, I spoke about some different aspects of it in this talk last year at the ICLS conference. If you're interested in human-centered design and how we bring that into learning analytics and AI, there are some accounts, insider accounts. I've been hunting for insiders, teams who are building these infrastructures, so they really know what they're talking about. But how are they engaging with some of these big questions about epistemology and pedagogy and politics and ethics? And there's a link there to some forthcoming volumes, including one that just came out yesterday in the Journal of Learning Analytics on Human-Centered LA. So, to wrap up, what might the future educational knowledge infrastructure look like? You know, are we looking for our own version of the IPCC? You know, an intergovernmental panel on learning, informed by the kinds of tools that we're in the middle of all developing right now? Maybe there is already something a bit like this. You know, there is a UNESCO Global Education Monitoring Report released every year. Now, this is a conventional form of educational knowledge infrastructure. If you look at any of those reports, they're using conventional data and statistics and outcomes. They're not informed by the kinds of very fine-grained micro-level analytics that we're all developing at the moment. But, you know, there's a piece of the jigsaw, perhaps. I don't think we can talk about the future knowledge infrastructure without talking about the increasingly influential roles that large multinationals are playing. They are, you know, innovating at an astonishing rate, building data sets of grand scale. They're building knowledge about learners, albeit from just their proprietary platforms. They only have a very particular lens they can look through. Those are generally intelligent tutoring system style lenses, but they will be expanding, of course, beyond those. There's no question there. And there are many questions and concerns being expressed about the role of these extremely innovative and very powerful companies in education and the tensions that arise around that. But that's just a crucial part of our future infrastructure. I think we need to have some very good conversations with our colleagues there. So to wrap up, we know what a functioning knowledge infrastructure looks like now. We know the influence that it can have on science and policy and practice. We know that's not straightforward and it can be controversial, but there are ways of managing that. So I think that these insights into what functioning knowledge infrastructures look like, they should help us, babies as we are, merely 10-year-olds, focusing in our efforts as we try and invent an educational knowledge infrastructure that is going to be sustainable, technically and socially, and trusted. And I'm very interested in your thoughts and reflections on this, both now and in the conversation forward. So I'll stop there for a few questions, and I'm interested to know what you think about that. Thanks very much.
Thank you, Simon, for the presentation. So we're going to have now a couple of questions. If you have a question, just raise a hand. Just click on the raise hand button or write a question down below. We're going to have, by the way, video recorded and posted to Google Group, where we're going to continue discussion after the talk, and also post recording of the video. So yeah, any question? Some noise.
If no one has a question for now, can I maybe start with one?
Yes.
Simon, thank you very much for this talk. It was very inspiring. And I noticed that during the talk I thought maybe you were leaning on two thoughts, or there could be two directions that one could think in. Namely, on the one hand, that we have this existing educational infrastructure, so our educational system, and which is an infrastructure in itself. And maybe we should incorporate learning analytics into this infrastructure. Or on the other hand, should we be building something totally new? So should we, invest in creating something new that incorporates both of them? So to what extent do you think it's one or the other, or maybe there's a third option?
Okay, interesting one. I mean, I don't think we're going to go anywhere fast if we simply ignore or can't engage with the huge networks that already exist in education. Okay, we have to do some good translational work. We have to be able to explain to our colleagues in the learning sciences, some of whom are nervous about quantification because they are qualitative people, and to the wider public who have concerns about data and analytics and algorithms, as well as to teachers in the school system, in the university system, policymakers in departments of education. You know, we have to build common ground with these people to understand where their pain points are. At the same time, by definition, they don't know as much about AI and analytics as we do. They don't know what's possible, and often they are excited and inspired by what they see when we show them examples of automated feedback on teamwork, or writing, or how analytics can now talk about self-regulated learning. They will have a stereotyped, fairly reductionist image, many of them, of what we mean by a learning analytics dashboard, because they've seen very simple examples and they haven't seen what's possible now in increasingly. So it's a conversation. We will be inventing things, but when in the lab, but if they have really got potential, they will need to be scalable and they will need to fit into existing practices and also, transform those practices too. I don't think there are many teachers who would say the teaching profession should look just like it does now in 50 years time, in 20 years time, right? Well, if it's not, well, what is it going to look like? We need to have the unions in this conversation as well. So I think we're talking about new technical infrastructure for sure, but it's going to have to interoperate with the social and organizational infrastructures that already exist. That is what the knowledge infrastructures perspective respects so much.
Right, because there's room for development even in the existing infrastructures.
Mm-hmm.
Okay, thank you.
Okay, anybody else got any thoughts? Can they just unmute themselves?
I think, yes, Irene, you think you should be able to?
Yes. Okay, so thank you very much for the talk, Simon. Actually, it's really interesting because I'm running a study in Estonia. I'm currently working in Tartu, in the University of Tartu, and I'm running a study in Estonia that kind of replicates the idea of Ken Holstein from CMU about superpowers and how we can develop, let's say, superpowers for teachers using learning analytics. And so I went to the teachers and I'm asking, okay, what is the superpower that you would like to have in order to make your life easier? And most of the teachers pointed at things that are either related to management, like school management. The school asks from them to do reports and to write essays and things like that normally they don't want to do. They consider it a task for administration. And the others were talking about lack of time, so they don't have time and they don't have personal time. So I saw that they had issues with their personal well-being that they were bringing into school, or vice versa. They were taking school tasks to their personal lives, and this would cause them problem. And actually, I'm not sure what to say to them, how we could help them. I mean, we can't really help them with that, can we? So that's my question.
Yes, well, this is what happens when you bring your end users into the design process. They will come up with all sorts of things. That, in a research practice partnership, where we take seriously the pain points that our end users have, then they may come up with all sorts of things which are outside of our power to do much about. So, we too have been using superpowers as a technique to get teachers to imagine, what on their fantasy wish lists they would like to see. We do try and focus them on things to do very particularly with a particular, kind of student activity, for example, to try and bound the conversation a bit. But it's always interesting to see what they come up with. But this is one of the interesting challenges also of co-design or participatory design for learning analytics. Unlike in other fields of human-centered design, our students, for example, they don't know very much about learning. They don't know very much about pedagogy. They don't necessarily know what is good for them. Often they will come out with suggestions that are not necessarily going to be very good ones to implement as learning analytics. And it's not our responsibility to try and implement whatever students ask for. What we want to do is give them a real voice in the process, but you know, we're not designing, it's not designed by students or designed by teachers. It's designed with them. Teachers equally don't know very much about technology. That's why we've been trying to invent these techniques that allows them to build a sort of common ground with technical people, but still have a voice that's heard and recorded and taken seriously. So yeah, that's a long answer to your question, but yeah, teachers live in a particular complex system, and their teachers and students may simply have their imaginations blinkered by the system that all they know is the current system, right? So if teachers have not had the chance to develop alternative pedagogies, it's very hard to ask them, how would technology help you transition to new pedagogies, right? If students have never experienced anything but lectures, they're going to ask for lecture recording and nothing else, right? So this is part of how I think learning analytics may be a bit like a Trojan horse. Mm-hmm. That learning analytics, if they embody a particular pedagogy, there are ways in which we can make those pedagogies easier to introduce, because they are adding value and tracking student behaviors that were never possible to track easily before. We can track students' behaviors in new ways. We can get at competencies that we've always recognized as important, but we never had a good way of assessing it. So, good question. But the fact that our stakeholders may come up with stuff that we feel we can't do much about is just part of the risk of engaging them in the conversation. And it's part of them also learning about what we can and cannot do with technology. Thank you.
Thank you. Thank you.
So we have another question by Abby. Just before that, I just want to say that I posted a link to Google form for feedback for the presentation. If you can just fill in that, there's in chat box. Abby, I think you should be able to talk now. Yeah, Abby, I think you're not muted. You just start talking.
Maybe Abby can post her question in the chat if she's still online.
Shall I pick up on Ishan's question here?
Yes, Dan, yeah, and we're going to continue.
So Ishan is asking, is there any kind of training in co-design that leads to more constructive results? That's something that we are busy working on. Carlos Prieto's PhD here at UTS is looking very specifically at that question. And, you know, one particular answer to that is that the co-design researcher facilitator plays a very important role. There is typically, you know, one or maybe two people, if you're lucky, who are trying to facilitate this whole process and move it forwards so that stakeholders are engaged and they know how to use these tools that we're introducing, and characterizing what that process and what those skills are is part of what we've been looking at with Carlos in his PhD. There are some papers coming out now that describe that, and he's building in particular on a framework that we've developed in my previous work that we call knowledge art, and I'll post a link to that in the Google thread. But if you Google knowledge art, you'll see a little bit about that. That is the skill of using visual representations to help stakeholders in participatory design engage in co-constructing the problem and the solution. The skill that a practitioner has in using these artifacts to help stakeholders step in and shape what's going on. So watch this space. We'll have more to say about what that looks like in due course.
Okay, thank you everyone. So we are now in a full hour, and thanks Simon for the great presentation. So we're gonna have this posted in Google discussion that you have in chat box, and also we're gonna email all of you with the link, and also it will be available for future on Solar website. So we're gonna be organizing these sessions once every 2 months. So just watch out for Solar newsletters and Google group. There'll be all posted announcements there. Thanks, Simon, and thanks everyone for participating.
Okay, thanks very much.
Yeah.
Goodbye.
Bye.
Bye.
Bye. Bye.